So now we need to calculate the standard deviation of productivity, which is given in percentage. Now the sum of squares is summation of yi square is equals to 9.5 square plus 26.5 square up to 35.7 square is equals to 17,688.16. Now we will calculate the standard deviation of this by using the formula by the given formula. So which is approx under root of 61.9576, which is approx 7.87. So we can say that we have calculated mean of age, which is 48, mean of productivity, which is 30.4, median of age is 51, and median of productivity is 30.7. Standard deviation of age is 50.80 and standard deviation of productivity is 7.87. Now a box plot or a box and whisker plot requires the 5-number summary: minimum, first quartile, median, which is second quartile, and third quartile, and last one is maximum number. Now for the age column, the 5-number summary, we know that a minimum age is 23, the maximum age is 61. We have already calculated the median, which is 51. Now the first quartile, median of the lower half, the first 9 values, which contains 23 twice, 27 twice, 39, 41, 47, 49 and 50. So this is the fifth value. The first quartile is the fifth value, which is none other than 39. So the value of Q1 is 39. Now third quartile, Q3. Median of the upper half, the last 9 values, which is 52, 54 twice, 56, 57, 58 twice, 60 and 61. So this is the fifth value of the upper half. So Q3 is 57. The 14th value overall. So the 5-number summary for the age column is 23, 39, 51, 57 and 61. As we know that 23 is the minimum number, 61 is the maximum number, median is 51, the first quartile is 39 and the third quartile is 57. Now we have to similarly calculate the 5-number summary for productivity column. We know that the minimum productivity was 7.8 and the maximum productivity was 42.5. Median we have already calculated that, which is Q2, the second quartile, which is 30.7. Now to calculate the first quartile, median of the lower half, which contains values such as 7.8, 9.5, 17.8, 25.9, 26.5, 27.2, 27.4, 28.2, 30.2. So here we will consider the first quartile as the fifth value, which is none other than 26.5. So Q1 is equals to 26.5. Now third quartile, median of the upper half, which contains values such as 31.2, 31.4, 32.9, 33.4, 34.1, 34.6, 35.7, 41.2 and last one 42.5. So this is the fifth value of the upper half, overall 14th value. So Q3 is equals to fifth value of this upper half, which is 34.1 and the overall 14th value. So the productivity for the column productivity, the 5-number summary will be 7.8, 26.5, 30.7, 34.1 and 42.5. As the minimum value was 7.8, maximum being 42.5, median 30.7, first quartile 26.5 and the third quartile being 34.1. So we have calculated the 5-number summary for both the columns. Now a QQ plot, which is quantile plot, is typically used to compare the distribution of a single variable to a theoretical distribution like the normal distribution, or to compare the distributions of two different variables. Since the request is to study the relationship using a QQ plot, we can compare the quantiles of the age distribution against the quantiles of the percentage productivity distribution. This requires sorting both data sets and plotting the ith sorted age value against the ith sorted productivity value. Sorted age is arranged as it is sorted, it is arranged from increasing value to decreasing value. And we have also sorted the productivity column. Now we have to plot the points xi, yi if the two distributions were identical in shape, only differing by location or scale. The points would lie on a line. Now here we have the QQ plot, which is age quantiles versus productivity quantiles. So on the x-axis we have sorted age, quantiles of age, and on the y-axis we have sorted percentage productivity, which is quantiles of percentage productivity. So this is the Q plot, and this red dashed line is the reference line. Now the QQ plot comparing the quantiles of age against the quantiles of percentage productivity is shown in the graph. Now the QQ plot analysis. A QQ plot is used here to compare the distribution shapes of two variables. If the two distributions had the same shape, differing only by location or scale, the points would fall along a straight line. The red dashed line serves as a reference for where the points would lie if the two data sets were perfectly identical. Now observation. The points do not form a straight line, indicating that the distribution of age and distribution of percentage productivity do not have the same shape. Thank you.